All right, let's talk about something that every single Python developer runs into, and that can make the difference between code that just works sometimes and code that's truly professional and robust. We're diving into mastering exception handling.
You've written this. I've written this. We've all written a line of code that looks just like this. It seems so simple, doesn't it? Just one little network request. But oh man, hiding inside this one line is a whole minefield of things that can go wrong. What if the Wi-Fi is down? What if the server you're trying to reach is offline? And boom, there it is. That big, ugly traceback that stops your entire program dead in its tracks. This is exactly what happens when we just cross our fingers and hope for the best. We're basically just assuming everything is going to be perfect, but in the real world, it never is.
So this brings us to the big question, right? When things do inevitably go wrong, is there a better way, a more graceful way to fail without the whole application just crashing and burning?
To answer that, we've got to get into the philosophy behind how Python thinks about errors. It's actually a little different from a lot of other languages, and it really shapes the way we're encouraged to write our code. First things first, let's get our terms straight. We are not talking about syntax errors. You know, when you forget a colon or a parentheses. An exception is what happens when your code is written perfectly, but something unpredictable happens when it runs, like trying to open a file that isn't there, or, trying to connect to a server that refuses you. Okay, this is where it gets really interesting. There are basically two schools of thought on how to handle these runtime problems. The first is look before you leap, or LBYL. This is all about checking conditions first. Hey, does this file exist? Okay, cool, then I'll open it. But Python prefers easier to ask forgiveness than permission, or EAFP. The idea here is to just be optimistic. Go for it, try to open the file, and if it turns out the file isn't there, then you deal with the problem in an except block. It usually leads to much cleaner, less cluttered code. So if we're going to be asking for forgiveness all the time, we'd better have the right tools for the job. And that brings us to Python's Core Toolkit for handling any exception that comes our way. Now, this whole structure is super powerful, and it's way more than just try and accept. First, you try the code that might fail. If something goes wrong, the except block kicks in to handle it. But here's the cool part. If nothing goes wrong, the else block runs. And then there's finally. Think of the finally block as your cleanup crew. It always runs, no matter what, whether there was an error or not. It's absolutely perfect for things like closing a file or a database connection, making sure you always leave things in a clean state. Okay, so you know the syntax, but just knowing the words isn't enough. Using them professionally is a whole other ballgame, and there are some really common mistakes that can turn this amazing tool into a trap that just hides bugs. And here it is, public enemy number one in Python exception handling, the bare except, especially when you just tell it to pass. This little piece of code is basically saying, hey, try to do this thing, and if anything, and I mean anything goes wrong, just, ignore it. Pretend it never happened. So why is this so terrible? Well, this quote says it all. A bare except doesn't just catch the file not found error you were expecting, it catches everything. That includes when a user hits Control+C to stop your program, or when the system itself is trying to shut down. Your code will just swallow those signals and keep on chugging, making your program seem frozen and just impossible to debug. So what do you do instead? It's simple. Be specific. If you're trying to open a file and you think it might not be there, then you catch file not found error. That way, if some other totally unexpected error happens, your program still crashes and shows you the real bug you need to fix. Never, ever use a bare except. At the absolute minimum, catch exception as E so you can at least log the error and see what actually went wrong. Okay, so handling exceptions is one thing, but now let's zoom out a little bit. Let's talk strategy. At a higher level, when a function fails, how should it even tell the rest of the program that something went wrong? You've really got two main strategies here. On one hand, you can return a special value, like none or false. This puts the responsibility on the code that called your function to check that return value every single time. Or you can raise an exception. This is totally different. It completely disrupts the normal flow of the program. It's like pulling the fire alarm. The calling code is forced to deal with it or the whole program comes to a halt. In Python, raising an exception is almost always the way to go. It's just clearer. But, and this is a big but, there's a catch, performance. Just look at this benchmark data. For a million tries, raising and catching an exception was over 8 times slower than just returning a value. Now, this doesn't mean exceptions are bad. It just means you should use them for, well, exceptional situations. If you have a condition that you expect to happen all the time, especially in a really tight loop, maybe returning a value is better. But for genuine errors, the clarity you get from an exception is totally worth it. And where does logging fit into all of this? That's a great question. The key thing to realize is that logging and exception handling are two different things. Logging is about recording what happened. It doesn't actually change how your program runs. So you don't choose between logging and raising an exception. In fact, you often do both. You log the detailed error message for yourself to debug later, and then you raise an exception to let the rest of the program handle the failure. You know, to really appreciate Python's whole forgiveness over permission vibe, it's super helpful to peek over the fence and see how other popular languages handle the exact same problem. So let's take a look. We've got Python with its clean try except. Then you have a language like Go, which forces you to deal with errors head-on. Almost every function returns two things, the result and an error. So you see that if error not nil check everywhere. And then there's Java with what are called checked exceptions, where you have to explicitly declare every single type of exception a function might possibly throw right in its signature. So what's the big takeaway here? Each one has a different philosophy. Go's approach is verbose, but it makes it impossible to forget about an error. Java's approach is really explicit and safe, but it can feel a bit rigid. And Python? Python's approach is flexible and clean, but it puts more responsibility on you, the developer. It trusts you to handle things correctly. Okay, so once you've gotten the hang of catching all of Python's built-in exceptions, the next level, the really powerful step, is to start creating your own. This makes your application's error state so much clearer. And seriously, look how easy this is. You just create a new class, and you have it inherit from Python's base exception class. That is literally it. By giving your exceptions clear, descriptive names like platform exception or invalid report format error, you make your own code 1,000 times easier to read and debug. So, I want to leave you with this final thought. We've spent this whole time talking about exceptions as a way to handle errors. But what if we start thinking of them as a design tool, as a way to signal important events in our program? How can you use custom exceptions not just to make your code more robust, but to make it fundamentally cleaner and easier for the next person to understand? That's where real mastery begins.